Alright. Stream should be live. Let's check. We are indeed live. Alright. Hello everybody. Today, I have not pinged my Discord yet, so I'm gonna do that. But today we're going to be working on just cleaning up code, optimizing the tree, not really focusing on adding new features. We're just going to be adding, like, trying to make the code cleaner, essentially. Let's see. At stream notifications. And let's grab the link. Discord has been summoned. And there we go. Let the stream commence. Alright, so the first thing I want to do is, well, let me actually show what I'm going to be working on first. So right now, in my test code, we got a bunch of addition and subtraction over here on this side of the equation and on the left side. And by the end of the stream, we want it so that all of this gets combined into a single constant that is then added or subtracted from the result of this equation. So it's kind of like just automatically combining all the constants here, and it almost does it. So we can see that all of this right here gets consolidated down to just 2. And then over here on the right side, this gets consolidated down to just 10. Now, because of how math works, we should be able to combine both sides. And I actually know already how I'm going to do that. So the way that we're... let me actually get out Microsoft Paint. Or, here, let me just put this into the Antler preview. Just so we can preview the parse tree. Okay, we need to load up this first. There we go. So this is what the parse tree looks like. So if we were to bring it and convert this into a operation tree, it would look something like 2 minus 2. For now, actually it's saying there's 2 people now. But yeah, for now you are the only chatter. But let's see. So we got 2 minus 2, then we add 2, so the result of this node gets taken down to add 2, and then result of this is taken down to, is it an add or subtract? I can't. It's another subtract. Minus 2, and then we kind of get a tree structure that looks like that. Now on the other side over here, we have like the A minus B times 6, and the side of that doesn't matter. It order of operation works and whatnot. Then this is plus 2, and then we take the result of that, and then we also add 2 to this again. So basically we just need to change it so that on this side we can take a constant from either this side or this side and apply the operation, because right now what's happening is all of this is being combined into a node right here. But it's without better graphics, it's hard to actually describe in a way that is understandable. And hopefully, me and Alex are working on a video right now, so we probably will have a graphic description of how that works. But yeah, so the first thing I want to do is right now in the operation nodes, this is what it looks like when I actually create the constants. So we grab the 2 constant nodes from the 2 arguments to, say, the subtraction node right now, and then we just subtract the values and return a new constant node. So what I want to do is make it so the constant nodes can automatically take care of this operation for us, so we don't need to copy it into every single node that would do this. So to do that, what I'm going to do is, in our value nodes, we're going to have a function here that will return. So the reason that I'm making a coding language in the first place is it's actually for my game engine, and the reason I'm not just using a pre-made one is a bunch of different things, but it's mostly to do with how calling functions in the script from main C stuff, the whole tree thing, because it makes it easier to optimize. That's the simple explanation. It's basically a different version of an abstract syntax tree, which is a different coding thing, but I convert it into a different tree format because it's kind of my own thing. Plus, later on, I want to add in a node scripting system. So using a type tree that's different from just the abstract syntax tree makes it so the nodes can create an abstract operation tree, or we can use syntax to create an abstract operation tree. So it's kind of like future planning for that, and also it makes it easy to optimize, because to optimize things, I can just give every node this optimize function, and then it will either return a pointer to itself or the new node that has been created to replace it, so they can kind of optimize themselves in a sense. So I'm going to create a thing here where the constant node can return if it is a numerical value or not. That way we can have a really simple way to not have to do any casting or not. In operation nodes, we can just say, okay, is this connected to a constant that is a number? So this will return if, so we'll just have return false if value dot type is equal to type ID of int and then for now we'll just have let's be more specific about this. We want 32-bit ints, 64-bit ints, floats, and doubles. Just like that. So if it's any of those, return true, otherwise return false. Now, so I'm not using an existing one because, so I will say this, I have a video that I filmed just yesterday that should be coming out as soon as we're done editing it, and I actually do answer that, and it will probably be a lot more concise than anything I can do just on the spot while my brain is in coding mode. But basically, zoom in on the text so we can see a little. Let me see about, I haven't figured out how to do it in C-line yet. Maybe it's like a, nope. So right now I'm making a coding language, and I'm not taking into account 8-bit or 16-bit numbers yet. I'm trying to keep complexity down as I build it, and then once I have the entire structure kind of built out, it will be easier to add other stuff in. So I'm just gonna turn this back to where it was. I think it was at, I want to say 24 before. So let's see, sea lion increase